Hey guys, so today we're going to be taking stoichiometry one step further, and now we're going to look at multi-step stoichiometric problems. So in the past we've gone grams to moles and moles to moles. We're going to take things further than we've done before, but the process is still the same. So if you need to review any of those concepts, feel free to go back to those older videos and take a look at those once more. Now whenever we're looking at a multi-step stoichiometric problem, we can convert between any of three things. We can convert between grams, number of particles, or volume of a gas at STP. Now for our purposes, we're going to focus only on particles and grams. During our gas law unit, we're going to talk about converting to volume of gas at STP. So whenever using the mole triangle, it's important to understand our conversion factors. To go from particles to moles, remember we utilize Avogadro's number, which is 6.02 times 10 to the 23rd particles per mole. And to convert between grams and moles, we utilize the molar mass of whatever substance we're actually looking at. So that's going to be in the units of grams per mole. In each of these cases, we can actually convert into moles first, because moles in any chemical equation is going to be kind of our common language. So let's do an example right off the bat where we look at a multi-step conversion. We're going to do it together, and then we'll let you guys do a couple on your own to practice. Alright guys, so we're going to start with a fairly straightforward example problem that I'm going to guide you through. Now our problem is asking how many particles, in this case atoms, there are in 27 grams of aluminum solid. Now in order to do this, we're going to write down what we're given, so we're going to start with our 27 grams of aluminum. Now, if you remember back to the stoichiometry we've done, we need to cancel out grams of aluminum and convert. Remember, with the mole triangle, the mole is our common language, which means we need to convert into the mole first before we can get into the number of atoms. So we're going to convert into moles. To go from grams to moles, we need to divide by grams and multiply by moles. This is effectively dividing by the molar mass of aluminum. Molar mass of aluminum is 27 grams per mole. Now that we're in moles of aluminum, we need to convert into particles, in this case atoms. Our conversion factor for particles is Avogadro's number, 6.02 times 10 to the 23rd. We need to convert into atoms, which means that's going to be atoms on top, moles on the bottom, which means we are going to effectively multiply by Avogadro's number here. Now, it's critical that you track your units in multi-step stoichiometric problems, because grams of aluminum are going to cancel, moles of aluminum are going to cancel, and we're going to end up in atoms of aluminum. If you do not cancel properly, you'll know immediately that you've done something wrong in terms of the steps of the problem. So if we multiply across the top and divide across the bottom, we'll see that 27 grams of aluminum solid have 6.02 times 10 to the 23rd atoms in that sample. So there you go. Alright guys, let's do a second practice problem. In this problem, we're given the fact that we have 1.204 times 10 to the 24th atoms of helium in a sample, and I need to know how much that sample is going to weigh. In order to do this, as with any multi-step stoichiometric problem, we're going to write exactly what we're given, which is 1.204 times 10 to the 24th atoms of helium. Now we need to convert out of atoms and first into moles, because remember, for our mole triangle, the mole is our common language. We can't go straight from atoms into mass. We have to go through moles to get there. So we're going to use our conversion factor, go from atoms to moles. That conversion factor, remember, is Avogadro's number, 6.02 times 10 to the 23rd atoms per mole. At this point, we've canceled out atoms of helium, and we're effectively in moles of helium. But we don't want to finish in moles of helium, we want to finish in grams. So we're going to have to use another conversion factor to get from moles into grams. This is going to be our molar mass of helium. If you check the periodic table, the molar mass of helium is 4 grams per mole. So what we're going to do is we're going to need to effectively divide by moles and multiply by grams. So we're going to effectively multiply by our molar mass. this is going to cancel out the mole of helium unit, leaving us with only grams of helium. We multiply all the way across the top, we divide across the bottom, and our result is going to be 8 grams of helium in our sample. So there you go. All right, guys, now I want you to try a practice problem on your own. So take a second, pause the video, work through this problem. If you get stuck or get an answer, unpause the video and we'll work through it together. All right, now that you've had a few seconds to work on it, let's go through this together. As always, we're going to start by writing down what we're given. In this case, 3.01 times 10 to the 23rd atoms of copper. We need to get out of atoms, and as with any multi-step stoichiometric problem, we have to get into moles first, our common value. So moles here are going to be converted through using Avogadro's number, 6.02 times 10 to the 23rd atoms per mole. Now that we're in moles of copper, we need to then get into grams of copper, because that's what our question's asking us. In order to do this, we need to multiply by the molar mass of copper. Molar mass of copper, if you check the periodic table, is 63.55 grams per mole. So we're effectively going to multiply by the molar mass of copper here by multiplying by 63.55. To double check our units, we're going to actively cancel out anything that is on top and on bottom. Atoms of copper cancel. Moles of copper cancel. And we're left only with grams of copper on top. What this means is we multiply all the way across the top, divide across the bottom, and we end up with our answer, which is we have 31.78 grams of copper. So that's going to be your answer. All right, guys, let's have you do this example. Now, I want you to tell me how many atoms there are in 266 grams of cesium. Take a second, pause the video, all right? Solve the problem. If you get stuck or get an answer, unpause the video, come back, and we'll solve it together. All right, now you've had a couple of seconds to work on this. Again, we're always going to start by writing out what we're given, 266 grams of cesium. Now, in 266 grams of cesium, I need to get eventually into atoms, but I can't do it directly. So I'm going to use Avogadro's number to get me into moles first, our common language. So we need to go to moles first. So we're going to get from grams into moles, and we do this by dividing by grams of cesium and multiplying by moles of cesium. This means we're effectively dividing by the molar mass of cesium. Molar mass of cesium is 133 grams per mole. Once we're here, we've effectively canceled out grams of cesium, and we've entered into moles of cesium. We don't want to end there, though. We want atoms, which means we need to use Avogadro's number as our conversion factor to go from moles into atoms. We're going to multiply by Avogadro's number here, 6.02 times 10 to the 23rd, to get from moles of cesium into atoms of cesium. We cancel out grams. We cancel out moles, and we're left only with atoms of cesium. We multiply across the top and divide across the bottom, and in the end we find that we have 1.204 times 10 to the 24th atoms of cesium present. So there you go. All right, guys, so let's have you work on this practice problem now. We have 6.02 times 10 to the 23rd molecules of oxygen. I want you to tell me how much that sample would weigh. Pause the video, take a second, solve this. When you get an answer or get stuck, come back and we'll work through it together. All right, so let's work through this together. Now, there's a tricky part of this, so if you didn't catch it, I'll show you what's going on here. We have 6.02 times 10 to the 23rd molecules of oxygen, so we're going to write out what we're given first. We need to convert out of molecules and into moles first. We're going to use Avogadro's number to do it. Now here's where it gets tricky. We need to convert into grams of oxygen, but this is grams of O2. Now the molar mass of O2, the molecule, is 32 grams per mole. If you only wrote 16, you accidentally did it for atomic oxygen, not molecular. Make sure you're very careful. Anytime you're dealing with gaseous oxygen, it's always O2. As always, we multiply across the top and divide across the bottom. We check to make sure our answer is in the correct units by canceling every other unit that does cancel, leaving us with just grams of O2. As a result, we find our answer here is going to be 32 grams of oxygen O2. So there you go. All right, here's another example problem I want you guys to work through on your own. Take a look at it. I want you to tell me how many hydrogen atoms are present in 18 grams of a water sample. So pause the video, take a few seconds, work through the problem. If you get stuck or get an answer, unpause the video, we'll work through it together. All right, great. Now that you've had a few seconds to work on it, let's go through it. We're starting with 18 grams of water, so that's the first thing we're going to write. We convert out of grams of water into moles of water first. This means we're dividing by the molar mass of water, 18 grams per mole. Now that we're in moles of water, be careful here because we need to go from moles of water to moles of hydrogen. Now, in order to do this, we're going to actually multiply by the number of moles of hydrogen in every 1 mole of water. This is 2 moles of hydrogen for every 1 mole of water because it's H2. Now, we're in moles of hydrogen, which means we now need to get to hydrogen atoms. We use Avogadro's number to get there. As always, we check our units. We divide, we cancel. So we cancel out grams of water. We cancel out moles of water. We cancel out moles of hydrogen, and we're left with just atoms of hydrogen. Now, we multiply across the top, we divide across the bottom, and what we find is that we have in this 18 grams of water, we have 1.204 times 10 to the 24th atoms of hydrogen. So there's your answer. All right, guys, so that wraps up today's video. Let's do a quick recap. Today, we discussed how to utilize at least 2/3 of the mole triangle to convert between multi-step stoichiometric problems. So this means going from grams to particles and particles to grams. Remember, we're going to be looking at that third part of the mole triangle, the volume conversions of gas at STP, once we hit the gas law unit. Now, as we were doing this, remember the key is tracking our units throughout the problems. Don't forget to do that, because if you do, sometimes you'll end up lost, and that's going to be an issue. I'd like to thank Eamon Doherty, Justin O'Dwyer, and Owen Flanagan for writing, filming, and editing this video. I'd like to thank you guys for watching. I'll see you in the next one.